Practice problem 3.1, global variables and sketch patterns. All right, we're going to look for places that we can use global variables, but global variables tend to be pointed towards the equations and being able to leverage that background information. So we are in millimeters, part in origin as indicated, so center of the part and lower. We'll probably use the contour and region for the overall geometry. Add another feature just to extend it down the additional step. So 12 millimeters. Just doing the quick look of dimensions, sketch lines, circles, sketch patterns, extrude boss, linear sketch pattern to create the teeth. All right, so teeth 18 from the edge. We'll double check that makes that centered. Angles. All right, so if I draw this from the top, and once again, there's not another ice view, but once again, I'm going to be looking at the front plane passing through the part. The top plane going across this lower edge, and the right plane going through the center of the part. What is that? Southwest to northeast. All right, so we're going to pull up our part metric. We're going to be on the top plane. Open up our sketch. Going to go with the center rectangle. Don't know that I have any real preference. The corners or the midpoints would work fine here, so. And did I not draw it? There it goes. Oh, I drug straight out. So if you do drag straight out and not give it any depth, that is going to kind of choke on the information. So 164 between centers, and we had the diameter of 16, so that will also be the width. And then we can go into our circles. Now for the circle, I'm going to look and try to get those little yellow dots up that say coincident. Tangent's fine. It doesn't, don't really think it helps, but it certainly doesn't hurt. And then our through hole is going to be 7.5. All right, so if I hit escape, I do want to pay attention that this circle was the last selected and it is still showing up in the selection colors. So holding down the control button and going to the other circle, I can set those to equal, go right into the smart dimension and place the through hole size. And then a quick right click to select or escape on the keyboard will get you up. So I don't really need the ends of the rectangle. It was just a convenience. So I'm going to switch those over to construction geometry. And then we have kind of that situation where the donuts are highlighted, the center isn't. And then we can kind of go from there. So since we're going to have multiple features anyway, and we're going to do the math for this, let's go ahead and extrude the center section, because with the shared sketch, we're going to be able to get from here to here, but then I'm still going to have to add geometry either lower or above to get it to that offset, to that length. So let's go ahead and extrude. We'll use the middle mouse wheel to zoom up a little bit, and that is going to be our 12 millimeter distance. Okay, going into the next sketch, make sure that you are expanding out next to the features so that you can see it sketch, and then extrude boss base. We're going to pick, and So on our drawing, we have 4 millimeters below. We've used the from and the direction, so our choice is that we could go from 4 millimeters below to 20 millimeters overall length, or we could do the math and say that it's going to go up 16 and down 4. Let's do direction 1 and direction 2. So 16 millimeters in direction 1, and in direction 2 we have 4 millimeters. All right, so the only difference in this and what I said first is that these add up to 20, whereas if I did the offset to start, I would be sending it down 4 millimeters, and then I would just have direction 1 going 20 millimeters. They both get there. It's which one makes more sense to you. All right, so we have our geometry in. Let's take a look at the teeth. So on the right end, we have a total of 24 teeth. And depending on the software, you do need to pay attention if it's doing the number of instances or the number of spaces. And so SolidWorks will use instances. Some other programs calculate like the distance between or the number of distances between. So it's a little more apparent when you end up with one more or one less than you expected. All right, so our tooth is 2.5 millimeters high, 2 millimeters wide at the tip. We're going to be 6 millimeters, so the 6 millimeters from root to root is going to be important because that's going to be part of our sketch, our sketch pattern. And then 18 off of the end. So I think that gives us enough. And then we'll just go ahead with the front plane. Again, our choices are the back, the front plane, or the front of the model, and then we go ahead with the sketch. So zoom in. Do not try to draw this from way out. Okay, so I'm going to start with a line across the bottom. So I picked up coincident. I'm going to coincident and bringing this back around. All right, so this is able to move side to side, so we're going to have to choose how we want to manage that geometry. Usually, I'll go right into center line. So underneath line, center line, pick the midpoint, and then we'll escape out of that. And I just want it to be vertical. All right, so what that's going to do is establish the symmetry that we're going to be able to create that geometry. All right, so we said 2 millimeters across the top. And the 18 millimeters is another interesting case because the cylinder where it passes through that plane will generate what's called a silhouette edge. And anything that's projectable into the plane that you're sketching in is valid geometry. So I can dimension off of that. I can dimension off of the other side of the cylinder. As long as that geometry remains valid, we're going to be able to pick it. All right, so from there to there, and notice that even though that intersecting edge, that where the front plane passes through the cylinder is back a little ways, the dimension still comes off of the current sketch plane. All right, so let's go ahead and place the dimension, assign the 18, and OK. All right, so our angle comes in with any two non-parallel lines, and 40. And then the overall, we might as well just go with the center line since it's convenient. There's the 2.5. All right, so up to this point, we've done similar things as far as sketches, creating geometry, and producing our models. This is where the sketch pattern really comes in. We did introduce the circular sketch pattern briefly, in one of the level 2. But with a linear sketch pattern, we're going to have the direction, the distance, which was the 6 millimeters. The number of instances is going to be 24. Let's make sure what that's, yeah, so display instance count and number of instances. If this was more like an array where we had rows and columns, then we would be activating the y-axis, and we would also be going up or down and left or right. All right, so we keep scrolling down until we get to the entities to pattern, and that's going to be my 4 items in the group. So since it's going to the right and not to the left, we're going to scroll back up, and wherever we see a direction toggle, we're going to be able to reverse that direction. All right, so another thing that we could turn on is the dimension the x spacing, and we'll see what we get with that. All right, so it happened to pick from tip to tip. The gear really doesn't care as far as that point to that point or that point to that point. It's whatever gives you the functionality. So I told it that there was 24 teeth, and we ended up with a little bit less. So either I missed the dimension. Oh, I can't type. That's never happened before. So let's just go ahead and accept. I want to see the, there it went, 134, 164. We go ahead and rebuild it. That looks a little bit better. Now I can jump back into the sketch. And what I was looking to do was create a driven dimension so that I could verify what we actually ended up with. Interesting, 20.18 on that side. So typically I'd want those centered so I could do the math. We're going to go with the geometry. It really shouldn't affect the volume calculation to have this shifted, but yeah, for a rack and pinion type gear set, I really would I would think that would have the same clearance on each end. But we are given the dimensions, and we're going to go with those. It's more of a, well, let's check and see what it's doing. All right, so I want to go to reverse direction and then up to next. How about through all? All right, so through all finds the last piece of geometry, and if there were more bodies out here for it to interact with, then we would probably go with up to surface, because then we could pick. All right, so you should start thinking in terms of what is the best end condition going to give me. The other one would be the vertex, which is any point or intersection of edges or lines. And what else do we have? Probably not an up to body. And then of course we could do the blind, but if the geometry changes, then those are going to come up short. So let's just stay with the up to surface, pick that surface, and then we know it's always going to generate that same geometry. So let's save this. We're going to create our new folder for the next assignment, or if you're calling them by level, then this is the level 3. All right, so want this to be 3-1. We'll save it, and then we need to find our values. So that was 38,144. And we're going to go into the evaluate, mass properties, and 38,144.1. All right, so I would like to check real quick. Since we had 18, let's go back to the 2.18, so that would be 1.09. So 19. and nope, needed to be 09. That's what I get for doing math in my head. Let's go ahead and rebuild it. And then we'll double check sketch 2. So 19.09, 19.09. And because the mass properties really shouldn't have changed, but if we go back and we look at the center of mass, that probably what would we be looking at? The y value probably shifts just a little bit. Or no, since the x is on 0 now because it's balanced, it probably had a little bit more in x. All right, so I have to go back and watch the video since I didn't pay attention when I first pulled that in. All right, so that's our first linear sketch pattern. We also could have done this with a feature pattern, but I'm going to use the features probably in the next video.